Hello, my dear students. Welcome to Class 9 Science. I am Soham Jagad. Welcome you all again. In last lecture, chapter number 10, Gravitation, we seen topic buoyancy and buoyant force. In that topic, we have seen one activity. In that activity, we take one plastic bottle, try to push it in water, and we feel that there is a certain force acting upward on bottle. We give name to that force, that is buoyant force. So we have now buoyant force and another name of buoyant force, that is upthrust force. So in that way we defined buoyant force. We also seen that there is also gravitational force is there, but due to buoyant force, this gravitational force will be overcome and it will move upward. So after that we seen a reason for floating and sinking of object on earth on surface of water. In that we done some activity. We put nail and a cork on water, and we see that nail sink in the water while cork floats in the water. And for its reason, we seen that there is a upthrust and gravitational, both are in case of cork and nail. But for nail, there is a less upthrust than gravitational force. So net downward force is higher in case of nail, while net upthrust force or net force, that is upthrust force, is more in case of cork. So cork float on the surface of water. We seen that reason after that, and we have mark reason for that. The cork floats while the nail sink. This happened because of the difference in the density. Yes, we seen another term, density. Density is mass per unit volume. Density is mass per unit volume. Here density of nail is higher that, and density of cork is lower with comparison to water. And we seen that the density of substance defined as mass per unit volume, and the density of cork is less than the density of water. This means that upthrust of the water on the cork is greater than the weight of cork. And if we want to float anything or any substance, its density should be lower. Then and only then that substance can float on the particular fluid. Density of iron nail is more than density of water. This means that the upthrust force of water on the iron nail is less than weight of the nail. So the weight acting downward will be more. So nail will sink. Therefore, we have conclusion. Object of density less than that of liquid float on liquid. Object of density less than the liquid float on the liquid, while object with the density greater than the density of liquid will sink in the liquid. So we have this conclusion. After that, we have seen Archimedes principle. In that, we seen one activity: take a piece of stone, tie it with a rubber string or a spring balance. We take one stone, tie it with not ordinary string. We tie it with a rubber string. Suspend the stone by holding balance or string as shown in figure. Now suspend this stone and mark the elongation of string. Here we have rubber string, so we know that when we attach any mass at the end of this rubber string, it will elongate or expand. Note the elongation of string or the reading on the spring balance due to weight of stone. Now slowly dip the stone in the water, a container as shown in figure. So we have one water container. Now we dip this stone with rubber string dip into this container. We can see that the length of this rubber string will decrease. Here we can see that here the length is comparatively more, and here in figure B we have comparatively less elongation or less length. So here we can write: observe the elongation of rubber string due to weight of piece of stone in air, while figure B, the elongation decreases as the stone is immersed in water. As we immerse the stone in water, elongation will be decreased. And in previous lecture, we discussed that it will happen due to upthrust force. And we seen one example that if I want to balance some substance in that particular in any particular place, I have to balance the forces. I have to balance the forces. So we have here two forces. One is the gravitational force, that is due to weight of any substance that is acting vertically downward, and another we have upthrust or buoyant force, that is due to liquid or say fluid in container. So we have one force downward and one force upward. So for finding net force, we have to subtract one force from another. Here we have sinking substance, that the stone will be sink if we release the thread. In that case, weight will be more. So the gravitational force, that is the weight of stone, will be more. So we will subtract upthrust force from weight of object. That is the loss in weight of stone. In this activity, we have seen that we feel loss of weight. We feel substance lighter in water. We may experience when we fill bucket from large water container, it will feel less weight while it is in water, but as and when we took it out, we will feel it comparatively heavier. that is due to upthrust force or buoyant force. So this upthrust force will be less from its original weight. So we feel less weight. You will find the elongation of string or the reading of balance decreases as the stone is gradually lowered in water. As we lowered the stone in water, elongation of string will decreases simultaneously till, however, no further change is observed once the stone gets fully immersed in the water. Here, decrement in the length of string will not happen infinitely. Means if we go deeper and deeper in the water, that will not happen. That string will be less and less and less and less and less. It will be decrease in, we feel decrease in length until and unless it will fully immerse in water. So when the stone gets fully immersed in water, after that we find no decrement in length of this string. What do you infer from decrease in the extension of string or reading of spring balance? We know that elongation produced in the string or spring balance, it is due to the weight of stone. Elongation in this direction, and that force that is acting in downward direction, that is weight. So this elongation produced in the string is due to weight of the stone. Since the extension decreases once the stone is lowered in the water, it means that some force acts on the stone in upward direction. As we discussed earlier, there should be some force if there is decrease in length of string. So here we have upthrust force which is responsible for decrement in length of the string. So we notice that some force acts on the stone in upward direction. As a result, the net force on the string decreases and hence elongation also decreases. We can note this reason, and in question we have to mention this reason for decrement of string length. So we have the net force on the string decreases and hence elongation decreases. As discussed earlier, this upward force exerted by water is known as force of buoyancy or buoyant force or upthrust force. This upward force exerted by water. Here in this experiment we have water, but in real life we may have any kind of fluid. I would like to say that we are also submerged in fluid only. Can you think we are in which fluid? We are in air now. We are in air now. We know that we have air, everything around us, and air is fluid. So we are called as body submerged in fluid. We are also completely submerged or immersed in fluid, that is air. What is the magnitude of the buoyant force experienced by the body? Is it the same in all fluid for a given body? Now we may have some question. What will be the magnitude of this buoyant force? There will be certain magnitude. Of course there is magnitude. Is this same for all fluids? Do all body in a given fluid experience the same buoyant force? The answer to this question contained in Archimedes' principle. Archimedes was very well-known scientist of Greek. He discovered principle subsequently named after him, that is Archimedes principle. We will in study it. After noticing that the water in the bathtub overflowed when he stepped into it, he ran through the stress he ran through the streets shouting Eureka, which means I have got it. In time of Archimedes, king asked Archimedes to check the purity of gold ornament which is made for king. In that time, we have no such equipments that can measure the purity of gold. So king gave this task to Archimedes to find the purity of ornament of gold which is made for king. So in continuous thinking of that, Archimedes find this principle of Archimedes principle which we learnt in few minutes. When he find it, he shout Eureka, Eureka, which means I have got it. What he has got? He has got the solution for problem. This knowledge helped him to determine the purity of the gold in the crown made for the king. His work in the field of geometry and mechanism and mechanics made him a famous. His understanding of lever, pulley, wheels and axle helped the Greek army in war with Roman army. Archimedes developed very good principle and few equipments that can help the army to fight in war. You might heard about another incident of Archimedes, that Archimedes used law of reflection to confuse the army. What he did, he has lot of reflecting surface, and by reflection he confused the army of another country, and by that he can protect his country only with reflecting surface, mirror like surface, and in that way he helped his king in such a great way. Let's see Archimedes principle. When a body is immersed fully or partially in fluid, it experiences upward force that is equal to weight of fluid displaced by it. When a body is immersed fully or partially in fluid, it experiences upward force that is equal to weight of fluid displaced by it. Let's understand this sentence or statement by bit. When body is immersed fully or partially, which means here we are talking about immersion of body in fluid, that is fully or partially. It experiences upward force. In above experiment, we seen that this stone feels upward force, upthrust, that is by water. So we can understand it. It experiences upward force. And this magnitude of upward force, this is important, is equal to weight of fluid displaced by it. Weight of fluid displaced by submerged body, immersed body. Let's take one example. If we have bucket full of water, bucket full of water, and if we drop one stone in that bucket, what will happen? Water will be came out from bucket because it was full with the water. If anyhow you can measure the weight of water came out from that bucket, you can measure upthrust force act by water on that stone. Again, if we take bucket full with water and immerse stone into that water, what will happen? Water came out. If somehow you can measure weight of water came out from that bucket, you can measure the upthrust force by water on that stone or any object. So I hope now you understood what will be the magnitude of upthrust force act by water or any fluid on object. Now can you explain why further decrease in the elongation of the string was not observed in activity 10.7? Now we can explain that why there is a no further decrease in the elongation of string, because now stone is fully immersed in water. So whatever the displacement of water should take, it take. No further displacement of water taking place in that case. So no further decrement in length of string will happen. Here we have reason. Here the use of Archimedes principle. Archimedes principle has many applications. It is used in designing of ship and submarines. Very useful. It is used in designing of ships and submarines. Lactometer, which are used in determine the purity of sample of milk. We have to mark it. This may be asked in 1 mark question. What is the principle of lactometer? Which equipment used to measure the purity of milk? Or another type of question we have, what is the use of lactometer? So we have to mark all these short questions. Lactometers, which are used to determine the purity of sample of milk, and hydrometers used to determine density of liquid, and hydrometer used to determine density of liquid are based on this principle, means Archimedes principle. So we have seen use of Archimedes principle, that is in submarines and ships. Lactometer, that is used to determine purity of sample milk, and hydrometer, that is used to determine density of liquid, that is work on based of Archimedes principle. Now we have another topic, that is relative density. Now we know the density, but here we have a relative density. As you know, the density of a substance is defined as mass of unit volume. Mass of unit volume. And now we know the unit of density is kilogram per meter cube. density of given substance under a specific condition remains the same. At particular situation, density of any substance remains same. Therefore, the density of substance is one of the characteristic properties of object. It is different for different substance. Density is different for different substance. For example, density of gold is 19,300 kg per meter cube, while that for water, density of water is 1000 kg per meter cube. What is the physical meaning of 1000 kg per meter cube? Which means if I take 1000 meter cube volume of water, if I take 1000 meter cube of volume of water, it will be mass 1000 kg. It has mass 1000 kg. Similarly, what is the physical meaning of density of gold is 19,300 kg per meter cube, which means if I take 1 meter cube volume of gold, it will have mass of 19,300 kg. I hope you can got the point. It is often convenient to express density of substance in comparison with water. This is density, that is particular density of that substance. But if we compare it with water, it will be more easier to deal with some kind of problems. So we have concept of relative density. The relative density of substance is the ratio of density to that of water. So the relative density is density of substance divide density of water. We have to notice that here we have density in numerator and density in denominator. So unit of density will be cut since relative density is a ratio of similar quantity. It has no unit. So I hope you got all the point we learned today, and take notes of all the point and remember all the point very well. Thank you.